In this episode, we're going to be building a fairly simple web application where we can upload images via dragging and dropping them, and then get back useful metadata about these images in JSON format. Finally, we'll walk through the steps of containerizing this application using Docker. Alright, you can see we have an area for dragging over the images here, and then over on my desktop we have a bunch of image files. So let's drag over the first image and get a feel for how this application actually works. After we've uploaded the image, we automatically get back this JSON block that contains all of the information about what we uploaded. Things like the image format, resolution, size, EXIF data, etc. Let's try another image. But why would you want to do something like this? Well, this image happens to contain GPS coordinates about where this photo was taken. Maybe you'd like to automate the extraction of this type of data and get back useful information in JSON format, which could be pretty useful. Before we jump into the guts of how this actually works, let's try one more image. This image happens to contain a bunch of data about the camera that took the photo along with its lens settings. Most modern cameras and phones automatically include this type of information when snapping a photo. You're likely wondering, why did I create this and why am I doing an episode about it? Well, this application works into a larger idea that I've been thinking about. I wanted to create a few example web applications so that we can containerize them and deploy them into production. Obviously, the UI needs quite a bit of tweaking on this, but the foundation is there. This will force us to work through all the steps and problems associated with actually getting an example application configured and deployed into production. So I'm thinking we take this concept and create a handful of image utility websites. Things like extracting all the metadata and showing it to the user, maybe image optimization, or extracting the GPS points and giving a Google Maps link. Basically, I want something that goes beyond the simple hello world type applications, where we can walk through the end-to-end process of actually running containerized applications in production. Not only this, but then we can walk through what an automated deployment pipeline looks like, with logging, monitoring, etc. It should be a really useful teaching tool. These will be real websites serving live traffic, helping people out on the internet, and you'll get a complete picture of how it works behind the scenes. I created a few diagrams that will hopefully help to explain what's going on here. First, the HTML form accepts uploads via Dropzone.js, which is an awesome JavaScript library for handling drag and drop uploads in your browser. From there, the uploaded file is sent to our HTTP server written in Go. This server writes the uploaded file to a temporary file. Then we call ImageMagick with a reference to this newly created temporary file we save to disk, where we then extract metadata about this image in JSON format. Finally, we capture the output from ImageMagick by way of our Golang app, and then we send it back to the user. We're also wrapping all of this in a Docker container, and then we're using Alpine Linux as the base image and installing ImageMagick. But you might be asking, why use Docker for this? Well, it just makes it so simple to run this application or send it to other people if they want to run it. Maybe think of it this way. What would happen if I didn't use a container? If you wanted to use this particular application, a dependency is having ImageMagick installed. You'd also have to download the source code and compile the Go app for your particular architecture, which potentially complicates things. Containers just make life so much easier, so why not use them? Now that you have a general idea of how things flow, let's jump back to the browser for a minute and walk through each piece. First, there's Dropzone.js, which is absolutely great. If you have any projects where you need drag and drop upload functionality, I'd highly recommend it. Next, we have ImageMagick, and it's very much like the Swiss Army knife of command line image editing. Like it says here, it supports over 200 different image formats, and you can do all sorts of cool stuff with it. How about we jump over to the command line for a second, and I'll show you what it looks like to extract this JSON data in a standalone version without the web app. So I have an example image here, and I'm going to use the convert command to extract the metadata from the image. Typically, you'd use this convert command to do things like converting between one format and another, or maybe resizing the image. But lucky for us, this convert command also supports extracting metadata in a variety of different formats. And here's the output. You can see here there's lots of different things about the image format, resolution, image properties, etc. Basically just what we saw in the web app. So if we go back to our diagram, hopefully this sort of flushes things out on how things are connected. Great, so that covers image magic. There's one other piece to this puzzle, and I added highlight.js. This basically takes that JSON block and applies syntax highlighting to it. This isn't essential, but it just improves the readability of the block that we get back. The reason I'm explaining this in detail is that I want to use this application as a foundation for a bunch of other applications in the future. So that's why I'm kind of going into detail here and there. Hopefully you don't mind. So now I thought we'd just jump over and look through the code really quickly and then build the Docker container. So you can see the folder structure here. But actually, I should mention that I've uploaded this code to GitHub and I've posted the Docker images to Docker Hub. The container and the code are all available. The links are in the episode notes below. I'm not going to walk through this in too much detail, in that if you're really interested, you can just go to GitHub and take a look for yourself. But at a high level, we have our static directory here, which has our JavaScript and CSS files. Then we have the template directory, which has our index.html file. This is our form. Actually, let's open up the index.html file. I'll just show you what the form looks like. There's honestly not much to this file. Basically, we have a form where dropzone is connected. And then down at the bottom here, we have this script block. This is where we're saying on any successful dropzone result, create a new code block where we're going to dump the JSON and then highlight the code. And then let's jump over to our server program written in Go. If we just jump down to the bottom here, it's actually very simple. We have a couple lines that handle serving static files. This is our JavaScript and style sheets. Then we have a couple lines here. The first one serves up the index.html template. And then the second one here handles uploading files. You can see there's nothing to the index handler at all. It basically grabs our index file and returns it to the user. The upload handler is a little more interesting, and you can see here I added some sort of notes to myself in research that I was doing while I was figuring out how to handle uploads. But the flow basically goes something like this. I generate a random file name that I'm going to use to save this file as. My general rule of thumb is that you never trust user input, so I wouldn't necessarily want to save the file with what the user provided. I'd rather generate my own, and then we can go off that. Then we grab the uploaded file. This is the form data that Dropzone is passing us. Then I print a little debug message just with the HTTP headers. This is on the server side, but just helps to make sure things are going smoothly. Next, make sure the temp directory exists, and then we go ahead and save the file to our temp directory with our random name that we generated. And then we call this probe function, which actually calls the convert command. I'll show you that in a second. And then finally, we return the results of this probe command back to the user's browser. One thing you might be thinking is, whoa, this is kind of hacked together. Hey, he's not doing any error checking. And you're right. For a lot of prototype type applications, I don't focus on error checking or making sure things are totally streamlined, in that I just want to prove the idea. And then if it actually is successful, I'll go back and polish things up. So for me, for this type of application, it's totally normal. I find this kind of funny in that the heart of this application is actually this probe function. And all we're doing here is we're basically running that convert command that I showed you at the command line earlier. So it's convert the file name JSON : and then we're returning the output of that command back to the user. So most of this stuff in this program is sort of boilerplate in setting up the web server and making sure that it all works correctly. I guess the only thing left is to have a look at our Docker file. So I'm using Alpine as the base image. Then I'm installing ImageMagick and Bash. Installing Bash is more of a convenience thing for me. Say that I need to connect to this container to do some debugging. It just makes things feel quicker in that I don't have to type out the complete commands I can use to have completion. Next, I'm setting up the folder structure within the container. This is where our Golang binary will sit, things like the JavaScript and style sheets, our template, and then the temp directory. These lines here are basically taking files from our local machine and copying it inside the container to our folder structure that we created up here. So this is our JavaScript and style sheets, our index.html template, and then the Go binary, which I'll show you how to create in a second. That's called web. These three lines down here basically define the environment, how our application should run. So we're setting up the work directory. So that's /app. That's where our app lives. Then we're exposing port 5000. That's the port that our Golang web server is listening on. And then we're setting the entry point. So when the container fires up, it'll execute our Golang web server. If you check out the code on GitHub, you'll actually find one other file. That's the README file. And in here, you'll find the commands that you need if you want to play around with this. Personally, I like creating these type of files even if I don't share it with other people, in that if I come back to this a few months from now, am I going to remember what these are? These are pretty generic, but in general, that's what I like to do. All right, so this command is what I'm using to build the Go web server. You'll notice that it's really long. Typically, you might just run go run or go build. In this case, I'm actually running on a Mac and I want to build this container for the Linux architecture because that's what I'm running inside my container. So let's jump over to a command line for a second. And if I list the directory contents, you can see there's no web binary file here. So I'm just going to paste that command that I copied from the README file, and that'll build our Golang web server. And then if I list the directory contents again, you can see that the binary's here. Then let's flip back to the README file. You can see that I have the command to build the container and then also push the container up to Docker Hub. So I'm just going to copy the build step here, and then we'll flip over to the command line, and then I'll paste it. So what this command is actually doing is we're saying docker build -t, which is tagging it. And so we're going to tag it jwysick/alpine image magic detect and then dot. So basically we're saying docker build whatever's in this directory and tag it with this particular tag. And that's the tag that's going to get pushed up to Docker Hub. This basically walks through each of those steps in our Docker file that we looked at earlier. So it's taking that Alpine image, it's installing ImageMagick and Bash, setting up our directory structure, copying over our file contents. And then the final steps are to set the work directory, expose the port, and then configure our entry point so that when the container boots, it's pointing at our Golang web server. And honestly, that's about it. What's kind of cool about this is now we have a totally self-contained program that we can send to other people. They don't need to install any dependencies. They just need to do Docker run and away they go. So if we flip back to the README for a second, so as I just mentioned, all that someone would need to do to run this container is type docker pull, the image name, in this case, this image name here. And then they do docker run -it. That's to create an interactive terminal. I included this just for debug sake since we're printing those lines when we process uploads, so it helps you sort of visually confirm what the program is doing from the console. And then I'm saying -p, which maps our ports. So the web server is listening on port 5000, so we want to expose that. This --rm, this basically tells Docker, hey, after the container is completed or shut down, delete it. The default behavior is to have the container stick around and outlive the run process. But for a lot of containers that I run, I just include --rm because they're sort of transient things and I don't really care if the disk image persists. So if you want to replicate what I've done in this episode, basically all you need is these two commands. Pull down the image and run it, and then connect to localhost. So we've covered the running the container part, connecting to the container, so it's just localhost 5000. I did add a few debugging commands if you're interested. Basically, this will allow you to connect to the container interactively, and then you can run the commands if you're interested in debugging it or just want to learn about it. Cool. So that's how we build a fairly simple end-to-end application and containerize it. Finally, I just wanted to leave you with Docker Hub and GitHub links. So up on GitHub, you can find all the source code, the Docker file, the README, all that. And then up on Docker Hub, you can find the actual container image. So you can just pull the image down and run it, and that's all you need to do. All right, that's it for this episode. Hopefully you found it useful. I'll see you later.